Hello everyone. So today we're going to solve an Oxford math admission question. And this question was asked in the 2019 entrance exam. And they wanted to know how many roots there were for this function right here. So let's just go ahead and start solving this. First thing we're going to start off is we're going to make everything, I want to make everything in terms of sign. So I'm going to use the identity sine squared plus cos squared equals 1. So therefore cos squared x is equal to 1 minus sine squared x. So plug this into here. Now I'm going to use a change of variables here because I noticed that this, if sine x was just some other variable, we have a cubic, which is slightly easier to work with here. So I'm just going to call s to be sine x. Then f of s is equal to s cubed plus 1 minus s squared. And this is the function we essentially want to find the roots for. And then after we found that, we want to plug it back into this and find the roots for sine x. So I've plotted sine x, and we're going to figure out what this function is right now. So first thing we want to do is we want to just plug in, well, before we plug in values, I want to see where the turning points of this graph are so we know what values to plug in. So let's just take the derivative. We get 3s squared plus 0 minus 2s. And to find the turning points, we have to evaluate this at 0. So 3s squared minus 2s. So 3s squared is equal to 2s. Here we divide both sides by s. So it's possible that s is equal to 0. And then we're left with 3s is equal to 2. So s is equal to 2 over 3. These are our turning points. So we know that there's going to be some interesting behavior at 0 and at 2 over 3. So I'm just going to, I want to figure out what the behavior is, to the right of this and also to the left of this. So I'm just going to plug in some arbitrary values into f of s just to kind of figure out what the graph's doing. So, I'm going to choose values that are easy for me. I'm going to choose something like -1, 1, and 0 just because they're easy to work with. So f of 0 is equal to just 1. F of 1 is equal to 1 cubed plus 1 minus 1 squared, which is just 1. F of minus 1 is equal to minus 1 cubed, which is just minus 1, plus 1, and minus 1 squared with a negative, so it's minus 1. So that's equal to minus 1. So at negative 1, we see that f takes a value of minus 1. At 1, f takes the value of 1. And at 0, f takes the value of 1. We know that according to our turning points, that there are turning points at 0 and at 2 over 3. So to kind of figure out what this graph is doing, we kind of want to know what's happening at f at 2 over 3 as well, because then it's easier to just plot this graph. So f of 2 over 3 as well. That way we know if it's, going up or down. So f of 2 over 3 would be 2 cubed over 4 cubed, 3 cubed. So that's 8 over 27 plus 1 minus 2 over 3 squared. So 4 over 9. I think if we simplify this, this is 8 over 27 plus 27 over 27 minus 12 over 27. That's equal to 423 over 27. And this is less than 1. This is less than this value. So we know it's not going to be upwards. It's somewhere here. So from this, we can plot the graph. And going back to the question, we want to find the roots of this. And we're going to use this graph to find the roots of that. So after plotting this graph, we see that the only root that this graph has is between -1 and 1. So we know that the root of s must be between -1 and 1. But we know that s is equal to sine x. So the root of sine x must be between -1 and 0. -1 and 0. Because we know that at -1 it's negative and at 0 it's positive, so somewhere in the middle it has to cross the x-axis. The fancy name for this is the mean value theorem, but it's essentially just crossing the x-axis at some point. So -1 and 0. So we want to find all values for sine x that are between -1 and 0 for a certain point. So when we look at our graph of sine x, we're only considering between -1 and 0. So we just ignore this part. And we see that for any value we draw, so this is a root and it has a specific value. So we're looking for one single number between 0 and -1. And for any number between 0 and -1 we draw, we see that there's two intersections. So suppose we draw a line here, there's 2. If we were to draw a line here, there's 2 again. And the only time that there's 1 is at -1. So our two options here are that there's 2 roots if the number is between 0 and -1, but not -1, or one root of the number is -1. But here we know that if it's -1, then the function must be at -1. Therefore, it's not possible that the function is -1, because then we would have a 0 here, which we don't. Therefore, we know that the root must be somewhere between 0 and -1, but not -1. So we know it cannot be this line. Therefore, it has to be some of these lines. Therefore, there are 2 roots, because the line crosses the sine graph twice. 4 sine cubed x plus cos squared x is equal to 0. Now notice here we take the restriction of sine x to be for x between 0 and 2 pi, because if we extend this further, then this graph is going to have more points where it crosses the line that we want. So we're taking this restriction, and under this restriction we find that there are 2 roots. So this was actually one of the multiple choice questions on the Oxford exam. There were a lot of them, and I hope you found this useful.